All right, so we're going to do concept again, the final concept, or I guess the concept of 3.1 again, beginning algebra, or sorry, intermediate algebra, college algebra. Talking about 3.1, talking about exponential functions, and now we're going to go to maybe just a decay situation. So if I've got a decay situation, this is a different situation. I'm talking about, again, just basic information from, what kind of information can we get from a function like this, f of t equals 100 times 0.4 to the tth power. We've got amount, f of t, of radioactive substance remaining after time, at time t years. So here's our t, f of t. The amount in grams based on t years is t, puts our t into our exponent. Our variable goes into an exponent, so it becomes an exponential equation. From this information, I can find that, or I guess I can make a parallel to the fact that, in general, our exponential function is f of x equals c times a to the x power. C is our starting amount, so in this situation, in my blue situation, f of x equals c times a to the x. C is my starting amount, so c, therefore, is my starting amount, 100. Initial amount, then, is 100. 100, and I would say, in terms of numbers, it'd be 100. Specifically for this situation, it's 100 grams. Decay factor, I always mention as well, decay factor A. Decay factor A is right here in our general equation. In our specific equation here in black, it's 0.4. So 0.4 is the decay factor. That's what we multiply every single entry to get to the next entry. So that is our decay factor A. From the black equation, we can just plot that number. Decay rate, then, again, A equals 1 plus R is the relationship between growth factor A and growth rate R. So decay rate R, specifically in this situation, would be, if we take the 0.4 as our growth, or sorry, not growth factor, but decay factor, 0.4 goes right here, equals 1 plus R, and if I simply subtract 1 from each side, I get my growth factor R equals negative 0.6. So R is negative 0.6 in decimal form, gotten from the fact that A is 0.4. Plug it into the equation, we get R equals negative 0.6. And if we've got decay rate of negative 0.6, decay rate in terms of percentage form is negative 0.6 times 100% gives us 60%. And keep in mind, it's negative. Negative 60% is our decay rate in percent form. Negative 0.6 is the decay rate in decimal form. Decay factor A is 0.6, gotten from the equation. However, we could start with the blue information and create our equation. If I gave you the fact that the starting amount was 100, I would have to know that, or I would know that. If I gave you the fact that my starting amount was 100, then I'd say that, well, C equals 100. If I gave you the fact that my decay factor was 0.4, then I could say, all right, well, my decay factor A equals 0.4. So we can go from the black equation into the blue information, or from the blue information into some pieces of information. And from this green information, I could say that, well, in general, f of x equals c times a to the x power. Specifically for this situation, f of t equals c. What's the starting amount that I was told in the blue information? If I was told the blue information and was told to create this, I could say that c, from this starting amount of 100 grams, that means that my c is 100. So c equals 100 goes right down there, times a. What was my a? Well, I was told that the decay factor was 0.4, so 0.4 goes right down here. That's a 0, by the way. 0.4 to the tth power, and there's my exponential equation right there. If I was given the blue information, I could create the green equation. Now, if I was told maybe a different situation, that perhaps, let's see, decay rate, let's see, if I was told that, hang on 1 second, get a better color. There we go. If I was told that decay rate R was equal to negative 60% or negative 0.6, then I could say that decay rate, if I was given the red information, if I was given this information, start amount equals 100. If I was given the red information, I could do the same thing. Start amount equals 100, let's say grams, then my C equals 100. Sounds good. if I was given a decay rate of negative 0.6, I'd have to say, or sorry, negative 60%, I'd have to say, well, that means that my R equals negative 0.6. That's a 0, that's a 6. R equals negative 0.6. Okay, and I got to find my A, because in general my equation is f of x equals c times a to the x. If R is negative 0.6, then my A is related to 1 plus R. That way, A equals 1 plus negative 0.6. 1 minus 0.6, A equals 0.4. And I've got my A information. I've got my C information. So here's my C information. Here's my A information. And I could again just create my f of x equals c times a to the x power as f of, specifically this situation, equals t. F of t equals 100 times my a, 0.4 to the x power. It's all related. Whatever information I've been given, I can create that black starting equation. And from the black starting equation, I can pull out information to give me my blue information as well.